Hello and good morning. We're back for section 10-2. It's titled Measuring Arcs and Angles. Yesterday we talked about 10.1, and that included things like diameter, chords, radii, and circumference. We just sort of went into all of this. There are videos. There's a video online already, and I'll link the playlist and each video on Schoology. So if you need to access it, either go to the profile below and find it, and you can use that to help you each given day. So we're doing 10-2 today. So let's start by looking at the slides. We'll go through the same slides from Schoology. Maybe one or two things cut out, things I don't even want you to consider at this moment, but things that I want you to see. So we start off, there's always preamble. We have stuff like this. Refer to circle F. So circle F, remember that's telling us to name the circle after the center point. That's why it's circle F. And a radius for this one would be LF, for example. We have three other radius as well. FO, FN, FM, all of those. Name a chord. We actually have a couple, many chords in this one. We have L to O is a chord. It's not one of our options. M to N is a chord. That's not an option as well. But O to M is given. There's actually a diameter and a chord. It's a diameter because it goes through the middle. We can do that one. Similar question. Something like this is something very similar to what we did yesterday. I would encourage you to pause the video right here, give this a shot, and see if you can figure this out. This right here given is 18. The radius of circle E is 18, and the radius of circle B is 8. If I wanted to solve this, also look on the 10-1 video to sort of see how we did something like this. We basically take this length is 16 for B, and then this length total for F to C is 36, and we take away 5. So that should give us, this question was only asking for B to C, and that'll be 3. Similar question, D to E, we can use any sort of combination. Once again, pause these videos, give these a try in your own notes. Content standards. And these are always included in every slide. And they have some things, some vocabulary if you like vocab and you think that that will help, go with that. So this is our first thing. The sum of the measures of the central angle of a circle with no interior points in common is 360 degrees. Hopefully that makes sense. Hopefully we see we have a circle given here, and all of these angles add up to 360. Not only do the sum of all of the interior angles add up to 360, but if you had a perfect diameter, cutting it in half, they add up to 180. We'll do one of those right now. So we have this right here. I will copy it down below, and I encourage you to put this in your notes as well. And it doesn't have to be perfect when you're doing this. They don't have to be crazy complex or even exactly the same, as long as you have some sort of thing to compare it to. So this is Q, this is R, this is S, this is U, V, and T is our center. So this is circle T. So let me just, we can get rid of that for a second. And so we just have this. We have circle T. You have one diameter, R to V. This is a diameter. The other ones are not. You could get pretty close, but they are not. So let's go back to the problem. We have a couple other little pieces we can throw in here. So we know this section right here is 20x degrees. We don't know this. We know this is 8x minus 4 degrees, and we know this is 13x minus 3 degrees. And lastly, this is 5x plus 5 degrees. Okay, So that is actually everything we know. And what we're trying to do is to find x. If we have x, we can actually find any of these 4 angles by just plugging it in. We have a couple options on what to do. We could either, if we just look at our previous slide, if we add all these up to get to 360, that would work. But we don't have this guy, and this is preventing us from doing that. We know nothing. We know nothing about that. So we can't, this isn't an x, it's not another variable, it's just sort of a mystery to us. So instead of doing all of it gets to 360, we're going to say these equal 180 degrees. The reason these are equaling 180 degrees is because this diameter is cutting it perfectly in half. So I know, yes, all of these are 360, but half of these are 180. So because I know those are 180, I can say 8x minus 4, 13x minus 3, and 5x plus 5, all added together, should get me 180. So 8 and 5 is 13. Another 13 should be 26x. Negative 7 plus 2 is minus 2 times minus 2. I can add 2 to both sides. So I get 26x equals 182. I need probably my calculator. 182 divided by 26. I get x equal to 7. So x is equal to 7 doesn't actually tell me what these angles are, but if I wanted to know what one of them was, all I would do is I'd take 7 and I'd plug it in. For example, if I wanted to know what this was, I could take 5 times 7 plus 5. I put 7 in for x. I get 35 plus 5, and that would be 40 degrees. So you can find all of these knowing this x. You could actually now find this one if you were in honors. I would encourage you to stop the video, find that on your own. It won't be on the slides, but if you find this and find all of them, you can add them up to 360. So once again, we had this. We had to go only half because to get 180, because we didn't have this. We had all of them. We could do either or. And if we see something that kind of looks like a diameter, we'll assume it is a diameter. So we'll go back to the slides. There's the problem we just did, and I'll walk you through it on Schoology if you need that. Those are all of our little pieces. If at any point you get lost or feel like it's going too fast, you can always pause the video, go again. There'll be office hours for any help you want. So we have this problem, very similar. I know 75, I know 5x minus 5, and 7x plus 2. All 3 of these, we have this angle, and this angle, are going to add up to 180. I know this because it is diameter from A to D, cutting in half. So I can look right here. We have this. These two together would be 12x. 75 minus 5 is 70, plus 2 is 72. So if I want to solve this now, I'll move the 72 across. 180 minus 72, 108. Okay, and then 108 divided by 12 is 9. So x equals 9. And look, it's one of our options. Great. So that is the first lesson today, is that we can add up all the internal angles being these, and we can add those up to get to 360 or 180, depending on what we're looking for. We have a new vocab words, we have major arc, minor arc, and semicircle. You know what a semicircle is, so I won't spend too much time talking about it, but we'll talk about major and minor arcs. We have a circle, and we'll put an angle inside of it. So there's our circle with our center, and we have something like this. We'll call that x degrees. This is circle C. And then let's go back to here. So we just look at the diagram for a second. We have C, we'll have A, B, and then let's put a point over here, D. So we have a circle with a couple points and an angle. We don't know what this is. It doesn't really matter at this point, but we have really two ways to talk about this. We have sort of, if I want to talk about an arc from A to B, I can do this. This is sort of your most intuitive. This is like your direct flight. If you're on an airplane, you go from A to B, and this would be written like this. AB with an arc right there. The measure of this is equal to x. So we could, it's pretty, for degrees, we can call it the measure of arc AB. But if we wanted to talk about this arc, we have to do a couple different things. We can't just say A to B because that's already being used. So if we want to talk about this all the way to this, we have to use a different term. We have to go from A to D to B. We could go B to D. That's the same thing. So this would be A, D, B. This is our major arc. As our major arc because it has more, it is sort of the longest way we can go, and this is our minor arc. So let's go back to the example. We have a minor arc is the shortest arc connecting two endpoints of a circle. Major arc is the longest arc connecting two endpoints of a circle. So we have from A to B, or from A through D all the way to B. If you add them both together, they should get you to 360 degrees. So once again, minor arc is our direct route, and our major arc is this. If we have it right in the middle where there's no longer or shorter way, that's a semicircle. So moving on. We have this right here. We have WC is a radius of C, right? Because I can see one. Identify X to Z to Y as a major or a minor arc. Just because there's three letters does not mean that it is a major arc. It is, in fact, a semicircle. It goes halfway around. We have another circle C. Identify W to Z to X. So it doesn't go here to here to here. We need to go W and end at X. So W to Z to X. So that would be, oh, let me go back one. It is a major arc, and it shares the same endpoints as XW. So it is all the way around except for 90 degrees, so it is 270 degrees. We have another one, W, XW. We want our shortest path, and it is a minor arc of 90 degrees. Here's another one we have. Find L to O. Well, we know that it is a minor arc, so we can eliminate C and D. And we know we're just going here to here. It's mirroring this right angle, so it's another 90 degrees. You can try these on your own, give them a pause, see what the answer is. This one would be C. Give a pause. That is D. So hopefully that makes sense. Theorem 10.1, in the same circle or in congruent circles, two minor arcs are congruent if their central angles are congruent. Hopefully that makes sense. I won't ask you for theorem 10.1, but it'd be something, hopefully by the end of it, it makes sense to you. So we have this graph right here. Refer to the graph, find KL. KL right here is this comfort section. And what we're trying to do is to calculate this. It is a minor arc. And let me just copy it down here, and then I'll show you what it's doing. It's giving you the answer already. That's okay. It is 21% of the whole circle. It's giving you the percentage in the pie chart. So if we know the whole circle is 360, all we have to do is find 21% of that. 21% or 0.21 of 360 is 75.6. Once again, we knew it was 21%. The whole circle is 360, so we would multiply 0.21 times 360. If we want n to j to l, that's going to be a very big section. It's a major arc. It's everything besides this pink and yellow sections. So to find NJL, I have to have three different sections I have to accommodate for. I have youth, which is 26%, mountain is 37%, and comfort is 21%. So what we're missing is 7 and 9, which is 16. So you have two options here. Let me show you this one. You have two options. We have option 1 and option 2. $26 plus 37 plus 21. So our first option. These are the different percentages that it encompasses. You can add those up. 26 plus 37 plus 21, and you get a 4%, and you go 0.84 times 360. That would be 32.4 degrees. This is probably the one I'd recommend doing, just taking the pieces you're given and finding that. What they did in option 2, I'll show you the slide again. So they said, well, we're not using 16% of the circle. 16% of it went unused. That's that 9 and 7. So what they did was say, okay, 60 degrees times 0.16 is 57.6. And then they said, okay, 360, taking away the piece I didn't use. So 360 minus 57.6, and if math works out, it should be 302.4%. Hopefully you see that these two are not different. They're just sort of approaching it from a different way. I would recommend this one. I think this one's a little simpler. Finding the things, adding them up, and then taking that. If you want to think this way, I don't think that'll hurt you at all. That's option 2 again, for the most part. Exactly how we talked about it. We have this one, find BC, that is 39%, that is B to C, that is a minor arc. 39% is 0.39 times 360, that would be 140.4. If you want A to C to B, we don't go this way, that's not correct. We'd go A to C to B. You would add all those up and find out what percentage. That should be 76% of the whole circle. So it's 27.3.6. Perfect. So we have another kind of problem here. We're kind of moving quickly because these should sort of start to make sense. We've talked about these ideas. Actually, in class for all of you, you've had a class on this, so it should still be in your memory, but we can teach it if it's not. Find LHI, that's here to here to here. And we see that L to J is a diameter. Since it's a diameter, we know all of these add to 180. Not only that, but 90 of it's right here. So I have 180. I've already cut out 90. If I just want to find this, I know this, my missing angle, and 32 add up to 90. I just don't need that in the problem. I'm looking for L to I, and we know that it is the supplement of this other right angle. So it is 90 degrees. There we are. If you can't tell, some of the animations are off, moving them into Google Slides, so it has sort of disturbed the order in which things come out. Here's another one I want to look at and try this one. I think this is an important problem just because it kind of shows how some of these problems are going to look. So once again, as most of these, we need a circle. We need, there's L, there's J. I actually have two diameters. There's H, there's K, and then here is I, more or less. And then M. This is, all right. I know this is 32 degrees. I know this is a right angle. So, what I'm looking for is I to J to K. I, J, K. So I want this measurement right here. Once again, I want here all the way down to here. I know a couple things. I know this is a right angle, so I can write that in. So this is 90 degrees. And I just need this one. If I add these two together, it works out. But I don't know what this is, but I have a couple things to go off of. I have H to K, that is my diameter. And so I know all three of these equal 180. Because H to K is diameter, so it's cutting it perfectly in half, so I know this is half of 360. So that means 32 plus 90 plus whatever is 180. If you see here, it also works for this one. If you notice, these are actually vertical angles. These are vertical angles. So if you found this, you could already use this. We kind of did this last question, but not really. We didn't need to go into that detail. So if I find this, I actually know this as well. And I could find this because these make 180 too. So once we find this, it'll really open up the rest of the circle. But all we need is this, our initial measurement. So I just need to solve this. 32 and 90 come together to make 122 plus something is 180. I'll take away 122 from 180, and that something is 58 degrees. So I know this is 58 degrees. That's not the answer to the question. I needed that to find it. The answer to the question, what is, let's go back and I'll show you, what is I to J to K? So our real answer, let's move this, the measure of I, J, K equals 90 plus 58. So our final answer is 148 degrees. Once again, we had the circle. We were given all the things in purple. We were given that this is a right angle and given that this is 32 degrees. We had to find this 58 by knowing that this is cutting it perfectly in half, and so these three make 180. So I found that to be 58. That was our missing piece. And then I looked back at the question. It was actually looking for this. So I said this plus this equals 148. So let's continue on. There's all the work as well. These are on Schoology. Print them out. Take your own notes. If you didn't get something or something wasn't clear, try going back and you can watch it as many times as you need to. Similar question, we actually keep the same circle. Actually, we changed that to 38 degrees. 38 degrees now. It's asking for EAB. That's another 90. Just another 90. BCD, you'd solve it the exact same way and get 142. Pretty similar, they just changed that digit. So this is probably the most important thing from 10.2. This is calculating arc length. This is calculating arc length. And what we're going to be doing here is saying, well, we have what percentage of the circle are we using? And then how much am I, what is my total circumference? So it's going to be very similar to when we did this kind of problem. We said, well, we're using this much percent of the circle, so we have this many degrees, paired with what we did yesterday in circumference. So we have L, the length of this, is whatever our ratio is, times our circumference. So let's do an example. I think an example would be the best way to sort of show you what's going on. We have this, find this to the nearest degree. So I will copy this down. We need, let me grab this blue. We have a circle. Specifically circle B. We have a radius, diameter, C, A, then over here to D. We're given this measurement is 40 degrees and this radius is 4.5 centimeters. So this is what we're given. The radius is 4.5. Radius is 4.5. So first I need to find my circumference. It's 2 pi r. We talked about that last in 10-1. If you need a reminder, go to there. So 2 pi r would be 2 times pi times 4.5. An exact answer would be 9 pi. 9 pi centimeters. 9 pi centimeters. So if I had a tape measure that was 9 pi long, it would wrap perfectly around the circle. The next question is, well, how much of my circle am I using here? I don't want the whole thing. I only want just this. It's the same question as what, if I have 40 degrees, what percentage of 360 is that? So if I plug that into my calculator, 40 divided by 360, I get 0.1 repeating. If we go to our calculator, there's a math button right here. You probably can't see it. And then the first option is fraction. We can take that repeating decimal and spit out a fraction instead. We actually like fractions a little bit more because they're a little bit cleaner. So that's also 1/9. So 1/9 of the circle is right here from A to Z to D. So I know all of my circle is this, and I'm only spending 1/9 here. So to find what this is, I need to put those two together. So if I'm only using 1/9, 9 pi is all of it, times 1/9. Those 9s are going to cancel. And I have pi centimeters from here to here. Pi centimeters. I knew that because I could find how much I have total around it. I can find how much I'm spending here. And I take those two answers and I multiply them together. So I get pi centimeters. So it's about 3.14 centimeters. So we found the length of dA, rounded to the nearest hundredth. Find the length of dA again to the nearest hundredth. I'll do this one as well. since we have nothing but time in our quarantine. All right, here we go. Another circle. If you have nothing else you can be doing besides taking notes, practicing your circles is not a bad way to spend your isolation. 28 degrees. There's A, there's C, there's D, and this is 6 centimeters. All right, we're looking again for AD, which is not the place we're given this. A to D is actually from here to there. We want this measurement, but we're given this. But luckily we know this guy is 180 minus 28. So we can find whatever this is. 180 minus 28, 152 degrees. Great. So that's 152 degrees. That's 28 degrees. I need to find my total circumference. 2 pi r. 6 is my radius. So 2 times 6 times pi. That's 12 pi centimeters. Great. So if I had the whole circle around is 12 pi centimeters long, or a little more than 37. A little more than 37. So now our second to last step, our penultimate step, is to find what percentage of the circle I'm using here. I have this, I need it over here. 152 degrees out of 360 degrees gives me my ratio that I'm using. 152 divided by 360. I get 0.42 repeating. I can put math fraction, see if it's a normal-ish fraction. It's 19/45. That's fine. We have a calculator. That's all that matters. So I take these two answers, and I'll combine them to get my final answer. We'll do that over here. Let's do it in purple to show that the blue and the red came together. So I have 12 pi centimeters in total, and I want 19/45 of that, or 4.2 repeating, to see how much I'm using from here to here. So 12 times 19 is 22845. I just have the pi sitting out there. So 228 divided by 45 is 5.0, we'll just say 6 pi. And then we can multiply that pi in if we're asked to, or if our multiple choice answer has that. And we get 15.89 centimeters. Perfect. So remember, we said that we had a little more than 37 total. And we're using 42% of the circle, so we have less than half. That's what we expect. So we have 15.89 centimeters from here to here. Hopefully that makes sense. If not, try it on your own. Maybe copy it down and you'll see some of the things I was doing in that one. And if you see here, they actually got a different answer. Not by a lot. They got 15.92. We got 15.89. All that will come from is where we round things. So depending on where things get rounded will be our deciding factor. So if I actually kept this, the 15.06 in its entirety, we probably would have gotten 15.92. Those are sort of the things that we're not too concerned about. Similar thing right here, we have D to A. It's almost exactly the same problem. They just changed 140 from 152. Please give these a try on your own so you can feel comfortable with what's going on. We have something like this. Find the length of JL, here to here. The most important thing in these problems is to know what section we're looking for. This problem would have a totally different answer if it said LK. If we wanted this, we could still do that. We just need to make sure we want J to L. So we take 36 over 360, that's actually 10%. We multiply that by the total circumference. This is your radius. Similarly, J to L. Pause the video, give this one a try. Just like the one we did together before. Finally here, one last one for you to try on your own. Here are your 3 options. Give it a try in your notes yourself. Perfect. 32.99. So I hope that makes sense. I hope this section isn't too hard. I think the hardest kind of problem for sure are these, where you have to find the circumference, you have to find the amount you're using and put them together. But I think thinking about it like this, you don't really have to memorize a formula. If you do want the formula, you do want to memorize that, it's in the notes, it's on the video. So go back, copy that down. I believe it is. You can reorganize it, but if you're looking for the length of this, it is this with your, whatever your angle is, over 360 times 2 pi r. It's just the same thing we've been doing, where we took this is this statement, and then we have our 2 pi r, which is over here, and they put them together. I did it sort of in 3 little places to all kind of make one thing. But if your brain likes this and thinks this way, please, please, please go ahead and do it. If you have any questions, please don't hesitate to reach out. I will have office hours soon that you can work on the worksheet and have all your questions answered. But until then, good luck.